In this demonstration, we will be creating a Claude Code context that can be used to generate .NET code written in C#. We will use Mermaid.js charts generated by Claude Code. We will define a set of common software requirements, a user registration, to specify, at a high level, our scope. From this specification, we will then generate a markdown document with pseudocode, which Claude Code can use to generate a Mermaid flowchart. We will also be using a Mermaid class chart to structure the models used in our workflow. The files we create in this demonstration can serve as a starting point for context engineering code generation for AI tools, including Claude Code. Let's start with the specifications of our user registration markdown document. The overview heading contains the following description. The interaction will consist of transforming data as it relates to user registration. This subsystem will need to be responsible for operating on user information including username, email, password. The subsystem will need to perform the following tasks. 1. Validate the input. 2. Check password complexity. 3. Check in a database if there is another user with the shared username and report an error. 4. Save the user registration in the database. 5. Send the user an email with a confirmation code that can be later used to confirm the user's email address. 6. Report any errors back to the user. 7. Write important events and errors to a log file. We have described both the information needed for a model, as well as the steps in the process that you might find in any similar user registration process. Now we will create some additional markdown documents that we will be using as our Claude context. These documents will consist of information about the directory structure, the technology stack, and an initial document that we will ask Claude to read, which references the other documents. We create a document which we will name directories. Our directory structure contains a directory tree as well as a bullet point list describing the scope of each directory. We have a directory named Pseudo-code, which will contain generated pseudocode. We have a directory named source, src, which will contain any generated source code. The source directory has a subdirectory named .NET, which will contain any .NET code that is generated. We also have a Mermaid directory, which will contain the generated Mermaid charts. Our next document we will name .NET. This will contain information about the technology stack used to generate .NET code. We have instructions to ask us for the project name before creating any projects. We have a section named .NET which outline the technologies we wish to use including the .NET language, C#, the .NET framework version, XUnit as the testing framework, and Entity framework for handling our data. The command section lists instructions for Claude Code to use when calling the .NET command. And additionally, the .NET Entity Framework scaffolding command we want to use for the generation of the Entity Framework context used for storing and retrieving our data. Our project structure section contains instructions about the naming of our solution and projects. We have included a solution file, a shared class library, integration and unit tests, and console application projects. We will add a document name initial, which will contain references to our other markdown documents along with instructions for Claude on which file to use, depending on the context which it is working with. We have included our directories document, our .NET document, and 2 additional files we will highlight in just a moment. These files are called Pseudo-code and Mermaid. Our Pseudo-code document is a text document published by Cal Poly named Pseudo-code Standard, which will be used to guide the Claude context when we ask it to generate pseudocode. This will standardize the structure used to declare variable, loops, subroutines, and other common aspects of written code. Our Mermaid.js reference document comes from context7.com, which is a curated collection of documentation for many packages and libraries that can be used as references for LLMs. We will be saving the raw text of this document to our project. We are now ready to start using Claude Code. On the left-hand pane, you can see the directory structure and files we previously discussed added to our project. This is a good time to commit everything we have so far to our source control repository. In our right-hand pane, we have opened up a Claude Code WSL terminal. The first thing we are going to do is issue the /init command. This will read the documentation in our project and create a Claude markdown file in our root directory, so Claude will remember what we are doing between sessions. We are now ready to issue our first instruction. We want Claude to read the user registration markdown document and generate pseudocode based on the operations. Our prompt will be as follows. Read the user registration markdown file and use it to generate pseudocode for the operations detailed. After Claude has finished generating the pseudocode based on our user registration markdown guidelines, we can look at the result in our markdown editor. Claude has generated subsections representing the sub-procedures defined in the initial steps we specified, numbered 1 through 7. If we review our initial user registration requirements, we can see that Claude has done a good job following the steps outlined and generating the pseudocode in the correct order with the correct separation of concerns defined in the sub-procedures. With the pseudocode generated, we are ready to have Claude generate the Mermaid flowchart based on the discrete steps defined by our pseudocode markdown file. We will use the following prompt with the appropriate @ to reference the pseudocode file. Use the @pseudocode/userregistration.md to generate a Mermaid flowchart describing the workflow outlined in the file. We will go to mermaid.js, use the menu to create a new flowchart diagram, and paste the contents of the generated Mermaid markdown into the left-hand editor pane. You can immediately see that we have an error in our markdown. Even when providing reference documentation, Claude does not always get it right on the first pass. Fortunately, Mermaid charts provide an AI tool that will correct most errors. We will use this to fix the errors in our markdown file and be sure to save the corrected version in our project. Mermaid's AI tool indeed corrected the errors in the document. We can now see the flowchart generated from our pseudocode, complete with notes, decision nodes for each conditional statement with path labels for true or false, error conditions, logging, and subprocess blocks, all in the correct order. Let's zoom in and have a closer look. Here we can see notes with a summary of the workflow. We can also see the input arguments used by the workflow, which we defined in our requirements. Note the decision nodes. These nodes are labeled to indicate what the decision is, and the branches are also labeled with a Boolean indicator. If we zoom in and look at the lower portion of our workflow, we can see there is only one path to a successful execution. All sub-processes must complete as expected, or the execution will return early with an error message after logging it. If all of our conditions are successfully met, a success message is returned asking the user to check their email. The flowchart gives us a very good visual representation of how our workflow accomplishes the steps involved in the user registration process. However, if we are going to generate code based on this workflow, it is helpful to provide more instructions regarding the input passed to the execution method. For this, we will create a Mermaid class diagram, which will represent an object that can be passed to this workflow. We will begin by creating a new class diagram. Here you see the user registration class. We definitely could have used Claude Code to generate this class diagram, but there is an important balance to maintain when using AI tools. You should generally select the tool that is going to be the most efficient to get the job done. Mermaid provides an excellent user interface for creating class diagrams, which are generally much simpler to define than, say, a workflow document. We are able to add properties and methods using the Mermaid charts UI and specifying the property type and name, as well as methods we may wish to scaffold when generating code. Here we see a simplified version of a class that could serve as a model for our user registration and passed into our workflow. We have properties for the email address and passwords, as well as associated confirmation fields common in any registration. We also see some Boolean values that might help us to identify the state of the registration as we progress through the workflow. We will save the markdown for this document in our Mermaid directory of our project when completed. In summary, we have generated documentation, charts, and reference material sufficient to serve as a context for Claude Code that could be used to generate working code. Our assets can be defined in two categories. The Claude instructional context on the left-hand side consists of the markdown documents we created or pulled online for the instructions given to Claude to assist in assets that Claude generated for us. We provided these documents. They include initial markdown, which is a reference index of sorts detailing the location of other documents. Directory structure markdown, the structure that should be used for any code generation, which we did not cover in this segment. .NET Markdown, the technology stack used for generating .NET code and projects. Mermaid reference text, which we pulled from Context 7 for Claude to use as a reference. Pseudo-code text, pulled from Cal Poly's website to be used by Claude as a pseudocode standards reference. User registration markdown, which is the list of 7 steps we wrote to instruct Claude on how to generate the discrete steps in our workflow. User registration class diagram document, which we designed ourselves using Mermaid charts. The second section on the right, generated context, represents the documents that Claude generated for us. User registration markdown in the pseudocode directory, which is the pseudocode Claude generated from the user registration markdown we provided highlighting the discrete steps. User registration Mermaid markdown, which is the flowchart Claude generated from the Claude-generated pseudocode. Thank you for watching our demonstration detailing how to use Claude Code along with Mermaid.js to engineer a context which could be used to generate working code. The example represents only a small portion of a complete application, but it generalizes the steps that can be used for other aspects of context engineering to facilitate development of your solution.